Alright, in this video we're going to put together the player health. So what I want to do is I want to create the current health that the player has as well as a maximum health that the player can have. And then certain objects in the world are going to cause the player to lose health but not necessarily die. So we're going to need to do that, create those variables first. Then we're going to put together a health bar script. And then we're going to put together some assets for the health bar, which will just be some sliding sprites. And then we're going to put together a script that allows the player to take damage and will cause the player to lose some health, in addition to displaying a nice little particle effect, in addition to showing where the knocking the player back a little bit. Alrighty, so let's go ahead and start with creating our scripts and our variables. So we're going to need to create some variables on our player to keep track of his maximum health as well as his current health. So let's start with that. I'm going to come up here and I'm going to say public float max health. I'm going to set this to a default of like 100. And I'll say public float health. And I'm going to make health a public getter and a private setter. And then I'm going to move that down next to my other property. Now, when the player gets awoken in his awake method, I'm going to say health equals max health. Okay? So in addition to that, what I want to do is I want to create a prefab that will be instantiated when the player receives damage. So I'm going to come up here to my public fields and I'm going to say public game object ouch effect. So that prefab or that object is going to be instantiated whenever the player takes damage. Alrighty, so let's go ahead and jump down into our methods. And I'm going to add a couple methods, or actually one method, to my player class. And I'm going to say public void take damage int damage. I'm going to say instantiate ouch effect at transform.position and transform at rotation. So that'll instantiate that prefab when the player takes damage. Then I'm going to say health minus equals damage. Then I'm going to say something like if health is smaller or equal to 0, then level manager dot instance dot kill player. So if the player has less than 0 health, he will be killed by the level manager, which will kill him, and then it'll respawn him in X amount of time. Which also means that when we do respawn, we want to reset our health to max health. So let's locate our respawn at method, which is invoked when the player respawns, and I'm going to say health equals max health to reset his health. In addition, I want to do one more thing. When the player dies, when his kill method is invoked by the level manager, I want to set his health to 0. The reason I'm doing that is so that when we die, our health bar goes down to 0, because there are instances in the game where there are insta-deaths. And in an insta-death, I want the health to be set to 0 so that our health bar displays 0 or displays empty when we die. Okay, so I'm going to create, I guess I am going to go ahead and create the health bar script because it is very straightforward. And we'll be creating one more script near the end of this video once we put or a couple more scripts once we put our health bar together so that the health bar follows the player around. But let's go ahead and start up here in code and add a new class, and I want to call this health bar. I'm going to hit enter. I'm going to remove the namespace definition. And then I'm going to say this inherits from mono behavior, which will bring in using Unity Engine at the top. So the health bar will need to reference a player so he knows which player he's displaying health for. So I'll say public player player. Then he's going to need a transform for his foreground sprite. This will make a little bit more sense when we create the actual health bar, but basically what's going to happen is the foreground sprite is going to get smaller and smaller relative to the background sprite, allowing the background, or allowing a progress bar, effectively is what this is, to be displayed properly. The next thing I want to do is create a public sprite renderer foreground renderer. That's because I want to change the color of the health bar as his health approaches 0. Now, what color do I want to use? Well, I'll go ahead and turn those into public fields so that they can be modified in the Unity inspector. So I'll say public color, and then I want to do, let's do max health color equals new color, and I'm going to pass in 225 divided by 225f, 63 divided by 225f, and then 63 divided by 225f. So why am I doing this? Why am I saying 255 divided by 255f, 63 divided by 255f, 63 divided by 255f? Well, that's because the RGB values of the color struct in Unity are represented as a number between 0 and 1. So for example, 0.1, 0.2, 0.3, and so on. But colors are commonly represented as an integer, or the components of a color are commonly represented as an integer between 0 and 255. So what I'm doing is I'm translating the normal RGB values into an RGB value that Unity understands. So I'm saying 255, 63, 63 for my RGB, and then I'm converting it into a way that Unity understands by dividing it by 255. All right, let's go ahead and create the other color, and this is going to be the min health color. It's going to be new color of, let's say, 64 divided by 255f, 137 divided by 255f, and then 255 divided by 255f. These are just colors that I had previously chosen that give us a nice red and green color. And what we want to do is when we display our health bar, we want to display a color in between max and min, depending on what percentage the player is at as far as his health. So now we're going to write our public void update method. The first thing our update method has to do is determine the percentage of how much health the player has. So we're going to call health percent equals player.health divided by player.maxHealth. However, for this code to work, for some reason I called health and max health floats. Health and max health, I don't want to be floats. I want to be integers. I don't want you to be able to have 0.5 health. So I'll fix that here in a moment by changing health and max health to float. But preemptively, before I change health and max health to integers, I want to add a cast in here to float, so that we perform a floating point division rather than an integer division, which an integer division in this case will always result in 0, whereas a floating point division will result in a number between 0 and 1. You'll notice that ReSharper is telling me that this cast is redundant, but it won't be redundant when we go and we change the types of health and max health to be integers rather than floats. Next up, I want to do two things. I want to set the foreground sprite, I want to set his local scale to new vector 3 of health percent 1, 1. So the x value will be between 0 and 1 depending on how much health the player has left. Next up, I want to set the foreground renderer's color property to color.linear interpolation between a value of max health color and min health color, using percent as the amount that we want to interpolate between. So this will give us a nice color.lerp will simply return me a color between this color and that color, using that as the distance between the two to apply. Alrighty, so that's our health bar script. And let's go ahead and jump into player and fix our health and max health. Again, I want my max health and my health to be integers and not floats. So I'm going to change max health to an integer, and I'm going to set health to an integer. By doing that, we no longer allow fractional health values, which is what we want to accomplish. Okay, so while we're in here, we might as well work on our component that gives our player damage, because we're not going to be able to test whether or not the player takes damage until we write a mono behavior that represents an object that can give the player a certain amount of damage. So let's go ahead and write that. I'm going to go up here in code and I'm going to add a new class and I'm going to call it give damage to player. And that's going to be the name of this script. I'm going to remove the namespace definition. I'm going to have this implement mono behavior because it is mono behavior. And then I'm going to create a public field and two private fields. So I'm going to say public int damage to give equals 10. Then I'm going to do something a little weird. I'm going to say private vector2, and I'm going to create two vector2s. I'm going to create one for last position and one for velocity. So what are we doing here? Well, we need to be able to track the velocity of the object that gives damage to the player in order to knock the player back per the velocity of, well, this object. So if this give damage to player is an object that's moving back and forth and back and forth and back and forth, we need to track how fast it's going. In order to calculate that, we can use some really, really basic calculations to determine that number, and then we can use that number to knock the player back based off of the values. Okay, so next up, I'm going to say public void late update. The late update method is going to be used to determine the velocity of the game object that this script is attached to. The reason I'm doing late update is because I commonly do all of my translations in my update method, and I want this method to be performed after all of my other translations. So I'm going to say our current velocity equals our last position minus cast to vector2 transform dot position divided by time dot delta time. So what are we doing? Well, we're taking the last position that we were at, subtracting our current position from it, and then scaling it down by how many seconds it took to get there. So if our last position was 5x and our new position is 7x, that means we moved 2 units in the positive x-axis, and then we want to scale it down by time dot delta time, which will give us our velocity, or how many units we are moving per second in the game world. The next thing and the last thing that we got to do in our late update is set our last position to transform dot position. Okay, so now we actually have to give some damage to the player. To do that, I'm going to say public void on trigger enter 2D collider 2D other. I'm going to say var player equals other dot get component player, because we only want this object to interact with another object that has the player component attached to his game object. Then I'm going to say if player equals null, return. That means we had a trigger enter event happen, but the thing that happened to enter our trigger was not a player. Next up, we want to say player dot take damage, passing in our damage to give, which remember, our damage to give is a public integer that can be modified in the inspector, but has a default value of 10. Alrighty, now let's grab the character controller out of the player. So we're saying var controller equals player get component character controller 2D. Why do we need this information? Well, in order to do the knockback properly, we need to know the velocity of the player and we need to know our velocity. We already know our velocity, but we have to get the velocity of the player. Who owns the velocity of the player? Well, the character controller does. So then we're going to say var total velocity equals controller.velocity plus our velocity, and that'll give us our total velocity. Now let's override the force. Now let's knock the player back. So I'm going to say controller.setForce, and I'm going to pass in a new vector2. And now I'm going to pass in two arguments. One for the force I want to happen in the x-axis, and the other one for the force I want to happen in the y-axis. So what I'm going to do is I'm going to say -1 times mathf.sine total velocity.x multiplied by mathf.clamp mathf.abs total velocity.x times 5, comma 10, comma 20. I'll explain all of this in a second here after I type out the next line, which is going to be minus 1 times mathf sine total velocity dot y times mathf dot clamp mathf dot abs total velocity dot y. We're to multiply by 2 and 0 and 15. Now these arbitrary numbers, well, actually, let's just go ahead and talk about what this formula does. Again, first of all, we get the total velocity, so the controller's velocity plus our velocity. Then we start off by negating whatever the result of this operation is. That's because we want to knock them back, not knock them forward. Next, we extract the sign from the total velocity x or y. So if the total velocity x is pointing to the right, we want to return 1. If the total velocity x is pointing to the left, we want to return negative 1. So this will allow us to make this formula work for both left, right, up, and down knockbacks. Now we enter a mathf clamp. The reason we enter a mathf clamp is I actually want to constrain the total force that the player could possibly be knocked back by different values. For example, we're constraining the total knockback of the x between 10 and 20. So a minimum of 10 and a maximum of 20. And we're constraining the total knockback in the y direction by 0 and 15. Finally, we get the total velocity x and y, their absolute values, because again, the sign is already being applied over here. So we want to take out the sign when we're working with these values. And to take out the sign of a number, we get the absolute value of that number. You can think of the absolute value as the distance between that number and 0. And then we scale it up by factors, in this case 5 and 2. Now we can totally turn these into variables if we wanted to. So we have a scaling factor of how much knockback to give in the x, a scaling factor of how much knockback to give in the y, the minimum knockback in x, the maximum knockback of x, the minimum knockback of y, and the maximum knockback of y. But we'll just leave these values as they are. They're values that I tweaked after a while and decided I like the feel of. But you could certainly turn those into public fields that can be modified within the inspector, and everything will just work. Alrighty, so we now have a knockback working. We now can give damage to the player. Now we can't visually see how much health the player has left because we haven't implemented the health bar, but so far the knockback and the death of the player if his health reaches 0 should both be implemented at this point. So let's jump it back into Unity, and let's give this platform right here. Let's make this platform a object that hurts the player. So it's a platform that moves back and forth and will hurt the player. The reason I want to choose this platform is because it's moving and we can test our knockback script. In order to make this object be able to give damage to the player, given our current way we had set up our give damage script, is to first of all set is trigger to true. Second, take it off the platforms layer, set it to the default layer. Why? Well, it's because our player can never actually enter this box collider if it's on the platforms layer, because that's what our character controller uses to prevent us from colliding with our geometry. Then once we set the is trigger to true on our box collider, we can add a component and we'll call it give damage to player. And then we'll keep the damage to give 10. Remember, our player has, well, let's actually give the damage to give 25. Because our player has a maximum health of 100. If he hits this platform 4 times, he should die. So let's go ahead and hit play and test our knockback. Alrighty, we have a frozen Unity. Go ahead and pause the video while I open my task manager up and yeah. Alright, and we're back. Unity just decided to freeze for for a couple seconds. But what it was really telling us is that we have an unassigned reference exception. The variable ouch effect of player has not been assigned. So if you recall, we use the ouch effect we instantiate that object when we want to give damage to the player. So right now, that object is null because we never actually created that effect, and because we've never created it, we've never assigned it to the player. Let's go ahead and fix that. I want to go ahead and create another particle system for our hurt effect, and I want to assign that to the player. So to do that, I'm going to open up my prefabs folder, and I'm going to pull out my small yellow burst. Then I'm going to come up here, and I'm going to say game object break prefab instance, and I'm going to rename it small red burst. My red burst, I'm just going to change by scrolling down to my color over lifetime, opening up my color, and changing it to a nice red value instead of a yellow value. So that should give us that burst. I'm going to come up here. I'm also going to change the red color right there. The white color right there to something like the red color right there, but maybe make it a little bit more dark. Let's see how that looks. I think that looks good. Let's change.
Yeah, I like that.
All right.
It's bloody. It's perfect.
Let's make this even smaller. Let's make it like 1. So we get a really nice little subtle effect. And then either bring its speed down or bring its speed up. I can't decide. Nah, I like that. It's very nice, very subtle effect. So now that we've created a small red burst, let's go ahead and prefabify it by clicking and dragging it over into the effects folder in our prefabs folder in our project. Now that we've done that, let's remove this from our scene. Let's click on our player and scroll all the way down, or not scroll all the way down, but just click on our player script, and then click and drag our small red burst into our ouch effect. Then let's go ahead and hit apply, so that that change applies to all of the instances of our player. And then let's hit play. Then let's hit this platform and see what happens. We indeed get knocked back, and we indeed die. So you see that when I hit it from underneath it, I get knocked back based on my velocity and the velocity of the platform. We can maybe make that effect a little bit, or that knockback, a little bit bigger. So if we jump back into Visual Studio and we open up our give damage to player, we can make the knockback a little bit bigger by maybe making its scale factor up to 6, and then set its maximum value to 40 instead of 20. Now that we've done that, come back into Unity, hit play. And I think I like that a little bit more, where we get knocked back a little bit more than we did before. So let's try to hit it again. Let's see if it, yep, there we go, and we die. Let's see what happens when I made this give way too much damage. So it's very difficult to test the knockback effect on it. Alright, so I think that'll work just fine for our knockback. It's not perfect, it's not a perfect formula, but I think it gives a good enough feel for what we're going for in this game. So that means the last thing we have to do in this video is go ahead and create our health bar. So our health bar will just be a child object to our player, and it'll just, well, be a health bar. But first, what we have to do is we actually have to create the health bar asset, because that's an asset that we haven't yet made yet. That was a redundant sentence. So to do that, let's jump into Photoshop, and let's just do something really simple for a health bar. What I want to do is come up here to I want to hit New, File New, and I want to give it a width of 256 and a height of 256. So that's a nice little square texture, and it'll actually, we can go even smaller than that, I think. I think it'd be fine if we I think if we did 128 by 128, I think this will be fine. Okay, so I'm going to go ahead and turn background into a layer, and then I want to go ahead and create the background of the health bar. So the background of the health bar, I'll go ahead and give the health bar the size that I want. I think that is a good enough size right there. Of course, we can scale it on our end if we want. Then I'm going to open up the options here. I'm going to set the fill opacity to 0, and I'm going to give it a, let's just give it a, we could make this kind of cool by giving this a, where are you, stroke? There, giving this a stroke, setting the stroke fills type to gradient, changing the angle to 90 degrees, and then what I'm going to do here is I'm going to make the health bar just a little bit smaller so that we can see that whole stroke. So I'm going to make it a little bit smaller and I'm going to move it down. And then I'm going to come up here in my stroke, and then I'm going to, let's see here. Let's just make it mostly black. Let's give it a really subtle little gradient effect. Make it mostly black, make it go from, I think that should be fine. Do I want to do 3? Or do I want to do inside or center? I think center looks the best right there. And then let's come in here and let's make this totally as flush with the edge as we can. You'll notice that I'm going to be losing a little bit of feathering. So in that case, maybe we can move it down a little bit and then move it a little bit to the right. Come over here and move it a little bit to the left so we don't lose that feathering. And I think that should be fine for what we want. Again, I'm not an artist, so yeah. All right, so let's go ahead and make the innards of this. The innards of this is really just going to be a layer that's going to be sized to fit, and it's just going to be a little block like that. I'm going to create a new layer. I'm going to fill in that layer. I'm going to come up here, and I'm going to create a gradient overlay, and I'm just going to make this a light gray that goes into a white. Then what I'm going to do is I'm going to bring this down here so that we can chop that up. So you'll see that I'm basically creating basically a texture atlas. If I had more UI elements that I wanted to add, I would put them inside of this particular PSD file. You'll notice that I have a lot of wasted space, but that's because textures, any way you write them, they need to be square and they need to be a power of 2. So the reason why I'm leaving a bunch of empty space here is so that we can now see how much additional space we have left over in this atlas to add additional sprites to. Okay, I'm going to go ahead and open up this folder in Explorer so that I can go back into Photoshop and hit save. And then paste in the path. So now I'm in my actual buzzsaw path. And I'm going to open up textures. And I'm going to go ahead and name this UI. Or how about GUI? And hit save. Maximize compatibility doesn't really matter. Okay, so now we have our GUI. Let's jump back into Unity and put together a health bar. So the health bar is going to start off as an empty game object, as most game objects do. So I'm going to come up here and say game object create empty, and I'm going to call this health bar. And then I'm going to move it down here. And then, well, no, I'm not going to move it down there. I'm going to center it at the origin. And the reason I'm centering it at the origin is because I'm going to be constructing a prefab out of this. Then I'm going to open up my textures, and I'm going to click on my GUI texture. And note that it's being imported in sprite mode single. Well, I actually want to change that to sprite mode multiple. And for the max size, I want to set that down to 128. and hit apply. Then I'm going to open up the sprite editor and I'm going to turn these into sprites, which I can just do manually right here. I'm just going to click and drag on the background, make sure that I get that feathering but nothing more, like that. And I'm going to call this health bar background. Then I'm going to do the same thing on the foreground. I'm just going to click and drag, get the whole foreground, and do health bar foreground. As far as the pivot point for the foreground, I'm going to set it to the left because we're going to want to grow this sprite from left to right. Then I'm going to go ahead and hit this apply button on the top right, and now I have health bar background and health bar foreground. Let's jump back into our scene view and place our background and our foreground in the scene. And those are really small. We'll size them up here in a moment. I'm going to place them both at the origin. Wow, those are small. Get bigger. All right, so let's go ahead and scale this guy up. Let's scale 10, 10, 10, maybe. Wow, that's way too big. 3, 3, 3. 4, 4, 4. You think that looks good? Maybe it could be a little bit smaller. 3.5 by 3.5 by 3.5. Actually, the Z scaling, I'll just set the Z scaling to 1 because it's irrelevant, because this is a 2D thing.
Yeah, 3.5 looked to be about the width of the player.
Yeah, I think that looks good. So let's go ahead and set the same values to our foreground, and then let's move our foreground all the way to the right-hand side. Now we have to worry about layer ordering. I want these layers to appear above everything in the game. So that means I want to include or create a new sorting layer. So I'm going to come up here to layers, and then I'm going to click edit layers, and I'm going to open up sorting layers, and I'm going to add a new one, and I'm going to call it UI. And I'm going to put it above everything, including the default layer. Now that I've done that, I want to go into my health bar foreground and my health bar background. So I want to select background and foreground, and I want to set their sorting layer to UI. The final thing I want to do here as far as sorting goes is I want to set the order and layer of my background to, how about 1? So that we can see that our background appears above our foreground, because our background is kind of not really a background so much as it is a frame. All right, so let's go ahead and put our health bar background and health bar foreground and child them to health bar. Now we have to worry about scaling. How are we going to scale this? Well, remember that we want to be able to scale this as a value between 0 and 1. You'll notice that we're getting a little bit of an artifact there, like a little bit of a see-through bit right there, probably because we're missing a pixel. But I think that actually looks kind of cool, so I'm going to leave it there. Okay, so we want to go ahead and we want this to scale from 0 to 1, where 0 is the whole width of the background and 1 is the width of filling the background. So how do we do that? That's a really bizarre thing to do, and unfortunately, to get it right requires a little bit of parent-child relationship trickery. What I'm going to do is I'm going to create a new empty game object, and I'm going to place that new empty game object at 0, 0, 0, and then I'm going to call this game object foreground container. Now I'm going to leave the foreground container as a scale of 1, 1, 1, and I'm going to parent it or child it to health bar. Then I'm going to take the foreground and I'm going to stretch it by holding down Shift all the way to the edge of our background of what I want. I basically want this to constitute a full health bar. Then I'm going to take the foreground and I'm going to parent it to the foreground container. Now you might think this really didn't do anything, but in fact it makes it so I can scale the foreground container from 0 to 1 and have the values properly represented. I do, however, want it to scale the other way. I want to set the pivot point so that when we scale, we're scaling from left to right. To fix that, I'm going to take the health bar foreground and I'm going to unparent it from the foreground container. And then I'm going to move the translation of the health bar container all the way to the left-hand side at roughly -2.1. Then I'm going to parent health bar foreground to foreground container. And now you see that when I resize it, or when I scale it up and down, it goes from left to right. So again, to do stuff like this requires a little bit of manipulation of how the parent-child relationships work inside of Unity. But I've effectively accomplished what I wanted, and that is having a scale between 0 and 1, determining this sprite filling its parent. Actually, I'm starting to really not like that little fuzziness at the end, so let's go ahead and fix that. I'm going to go back into my sprite editor on my GUI. I'm going to say sprite editor. I'm going to scroll all the way in, and I'm just going to come here and I'm going to chop off 1 pixel here, and then I'm going to hit apply. And that might remove that ugly feathering that we were seeing there. As we see, it does. However, because we changed the width of the sprite, notice how we've now broken our scale relationship. So let's go ahead and scale this child all the way up to being the full width of the parent. And now we have our scale relationship back and working the way we want it to. So effectively what we've accomplished is allowing our foreground to scale from a normalized number between 0 and 1. In addition, you'll notice that if I come in here and change my color does indeed work the way I want it to, by just tinting that color. Maybe we can make the gradients a little bit more obvious in Photoshop, but we won't worry about that quite yet. Okay, so let's go ahead and take the health bar and let's move it on top of the player, up like that. So we now have a health bar. Then let's go into our health bar and add a script to it. The script we're adding is called health bar. So let's go ahead and take the player. So I'm going to click on this little, instead of locating the player in the hierarchy, when our hierarchy gets really big like this, we could also click this little button on the right-hand side and say, I want to look in the scene and I want to grab the player, because the player is the only object in the scene that has the player component. Therefore, it's the only object that appears in our selector. Now let's select our foreground sprite. So again, I'm going to click on this little arrow button and I'm going to scroll down to health bar foreground container right here. Now, foreground container is the transform that I want because that's what I'm going to be using to scale from 0 to 1. Now we want our foreground renderer so that we can change the color. I'm going to click that little button again and scroll down to the health bar foreground. Double click that and we should be good to go. Let's go ahead and hit play and see what happens. As you see, our health bar is blue, but as we hit this magical little platform that hurts us, we see that it goes down, it goes down, it goes down, and it reaches 0. All right, so that is our awesome health bar. However, you'll notice one big problem with it. It doesn't follow the player. Now you might be thinking, well, we can just go ahead and parent the health bar to the player and all will be good. The problem with that, however, is the scaling of the player when he flips from right to left. If the player flips and does so by setting his scaling to -1, that's going to result in the player the player's health bar being backwards. There are a couple potential solutions for this. One of them is to go in to the player object and parent all of his physical attributes or all of his sprites that I want to flip to another game object and then set that object's scale to -1. That way the player's scale is always +1 and our health bar won't flip backwards. However, we could also write a script that will have the health bar follow the player around. I think from a teaching perspective, that solution is a little bit nicer because it allows us to show or demonstrate the creation of a script that can follow an object around without being parented to it. And I think that's a really important script to have in your arsenal of code. But again, we could accomplish the same thing by taking all of these child objects of parent player and placing an intermediate empty game object between the player and all those objects. All right, let's go ahead and create the follow object script. The follow object script is going to be very, very, very straightforward. All it's going to do is it's going to take a reference to an object and an offset, and every frame it's going to set its position to the thing it's following. So let's jump into our code. Let's open up Visual Studio, open up our code folder, and insert a new class called follow object. A follow object will inherit from mono behavior, and we are going to take out the namespace definition. Follow object will have two public properties, or two public fields. One public vector2 called offset, and one public transform called following. He'll have one method called update. Inside the update method, we'll say transform position equals following.transform.position plus cast a vector3 offset. So all this code does is it has one object follow another object given an offset. So let's jump into Unity and let's open up our health bar. Now let's come over here to add component and say follow object. For the following, let's click this little button right here and say following player. And so we'll be following the player's transform. For the offset, let's leave the X offset at 0 and the Y offset, let's set it 2. I don't know if that's going to be the value we want, but it gives us a starting point. Now let's hit play. And we see that the health bar does indeed follow the player. Let's go ahead and actually set that to 2.5. Alrighty. So now we have an awesome health bar on our player. We have give damage scripts, our health bar resets properly and all that fun stuff. I'm starting not to like the size of the health bar. I think it's a little bit too big. So let's go ahead and fix that by going into our health bar background, and changing its scale from 3.5 to maybe just 3, or maybe even just 2.5. I think 2.5 looks good. So let's jump into our health bar foreground. Let's change its Y scale to 2.5, and then let's resize it by holding down Shift to fill the entire health bar. However, we will run into a slight problem. Our foreground container is now not working properly because it was set up with a parent-child relationship before that's no longer present because we've changed the scaling of our objects. A very easy way to fix this. So this is just another example of how the way things are parented can affect your transforms. One of the easiest ways to fix this would be to change the position of the of this object to maybe -1.5, or how about 1.54. Then we go into the child and we change the child's position to match the position of that object. And we're just going to eyeball it. Now that we've done that, we can go to the foreground container and we can see that our scaling now works properly. We will notice, however, that I did introduce a little bit of inappropriate Y scaling or Y movement. I'm just going to take the foreground container and I'm going to move it down, or no, I'm not. I'm going to move it like that. Then I'm going to take the scale, the Y scale of my health bar foreground, make it bigger, and then move it down just a tad. Now I'm going to hit play, and we see that the health bar is a much more reasonable size. In addition to the health bar being a more reasonable size, we also see that its scaling works properly, just like we expected it to. Alrighty. So I think that pretty much wraps up what I wanted to do with the health bar, with giving damage scripts and all that fun stuff. So we'll see you guys next video.